Okay, we're going to talk about the role of the loop of Henle in this video. Okay, so the role of the loop of Henle is to make the medulla, to make the renal medulla very salty, to make the concentration of sodium chloride very high there. And the reason for that is because the collecting ducts, okay, I'm going to draw them in here. So these are the collecting ducts. Yeah, they're going to pass through the medulla, which has got a very high sodium chloride concentration, and that will remove water by osmosis from the urine and the collecting ducts, and make the urine much more concentrated and stop you losing a lot of water. Okay, so let's have a look at the structure of the tubule here before we talk about how the loop of Henle actually manages that. So we've got our proximal convoluted tubule in the renal cortex, and then it dips down into the filtrate, dips down into the loop of Henle, into the medulla, goes deeper and deeper into the medulla, and then it will come back into the distal convoluted tubule, and finally the urine will pass through the collecting duct in that direction. Now the loop of Henle, as I've shown here with this red triangle, the thickness of the line shows the concentration of the sodium chloride. You see it gets more concentrated as you go deeper and deeper into the medulla. So that means the urine passing through the collecting duct, right, is going to pass through a very concentrated solution, and that's going to draw water molecules out of the urine, and that water can then go into the blood vessels in the renal medulla, and it's essentially retrieved rather than being excreted in the urine. Also, you can probably see there that where the urine and that part of the collecting duct is going to be quite dilute because you haven't removed any water from it yet, much water from it, and there the concentration of sodium chloride in that part of the medulla here is not that high, but it's high enough to remove water from dilute urine. Now, as the urine gets further and further down here, it's going to become more and more concentrated till it gets to the bottom here. It's going to be very concentrated urine, but the medulla can still withdraw some water from it, because at that point the concentration of salt is really high. So let's see how the loop of Henle actually achieves this, making this concentration gradient in the renal medulla. Right, so here I've drawn a diagram of the loop of Henle in a bit more detail to show you some. So you can see there we've got this descending limb, and it's called descending because the urine, the filtrate, is flowing that downwards in that part, the descending limb. And then you've got this, it does a U-turn here, and then you've got the ascending limb. The first bit is called the thin ascending limb, and then it becomes thick there. Now, the story starts off really, although the urine comes in here, the story starts in the thick ascending limb. Okay, now the thick ascending limb can pump sodium out of the filtrate, so that's what's going to happen. So you're going to get sodium is going to be pumped out by active transport out of the filtrate all the way along the thick ascending limb into the interstitium. So this is the interstitium. Just to explain how it does that, it's very similar to what happens in the proximal convoluted tubule. So here we've got an epithelial cell lining the tubule, and this is the lumen side. So this is where the filtrate, the urine, is. Okay, on the other side, so it's the basolateral side, you have an ATPase here. This is sodium potassium ATPase, active transport. It pumps 3 sodiums out and 2 potassiums in. That, of course, is going to lower the sodium concentration inside the cell. So that means passively then you are going to get sodium entering the cell here out of the filtrate. In actual fact, it's co-transported with potassium and 2 chloride ions as well. So that's the potassium and the chloride are they could be down the concentration gradient, it could be with the concentration gradient, but the sodium is moving down the concentration gradient there through that carrier. So in that way, sodium passes from the lumen side to the interstitium. So if we see there, that's what's happening. That's what's happening in the ascending limb. Now we need to talk about the descending limb now, because the descending limb is impermeable to sodium ions. No sodium ions can leave or enter the descending limb. But I should say the thick ascending limb is impermeable to water, so no water can leave or enter the thick ascending limb. It's the opposite way around. The descending limb, water can pass into the descending limb or pass out. And in actual fact, the water is going to pass out of the descending limb. Why is it going to do that? You can probably see why is it going to do that. It's because, well, what can we say about the concentration of sodium here in the interstitium? It's quite high because the thick ascending limb is actively transporting, pumping it out. So water will leave the descending limb, and it's going to leave the descending limb all the way down. You're going to get water coming out of this. The sodium ions have to stay put. So you can probably realize there that what's going to happen is at that point there, at the bottom of the thing, you can have a very high sodium ion concentration inside the tubule, not in the interstitium, but inside the tubule. Now, when it gets to the thin ascending limb here, so when it turns the corner, the thin ascending limb allows Na+ to come out, to leave. And the sodium is going to want to do that because you're going to have a very high concentration of sodium in this limb. So it's going to dump all of those sodium ions, are all going to be dumped out here passively, or going to pass out. So that is going to make the concentration of sodium very, very high at the bottom of the limb. So you can have a really high concentration of sodium ions and chloride ions there. And as it goes up the ascending limb, of course, then the sodium ions are starting to be pumped out, so the concentration will gradually decrease as you go up. So that is how the concentration gradient in the medulla is generated by the loop of Henle. And it's all achieved really by having one side of it permeable to water and the other side permeable to sodium. And also in this thick ascending limb here, you've got active transport where you've got using lots of energy up to chuck out loads and loads of sodium here, which is going to have the effect of making water be withdrawn from the descending limb. Okay, and just to, before we finish, just to remind ourselves then, as that the urine comes down here, down the collecting duct, if there's ADH present, antidiuretic hormone, then that will mean that the collecting duct is permeable to water. So the water will pass out by osmosis due to the high concentration of sodium in the medulla.